Hello everyone, my name is Hazim and today I am presenting DeepTective. In this work, we provide an overview of DeepTective, a machine learning model which detects SQL injection, cross-site scripting and OS command injection vulnerabilities within PHP source code. A brief introduction on the topic, PHP remains the most common server-side language on the web, especially among small and medium-sized websites. Due to the amount of economic activity taking place online, PHP web applications remain a tempting target for malicious actors looking to exploit the security vulnerabilities for their own financial gain. In order to preempt the compromise of PHP web applications, there has been a steady and growing interest by software developers, security firms, and white hat hackers to find, fix, and disclose these PHP vulnerabilities. Motivations and problems of the study. The first problem is that manual human analysis is slow and inconsistent when they're trying to do things. Human tends to make mistakes over time when they're doing things repeatedly over and over again. The second problem is that static analysis often introduce lots of false positives and false negatives when they are trying to detect vulnerabilities in the source code. The third problem is that existing tools, they suffer from limited detection performance, especially when they are dealing with real-world source codes. This is because these tools were trained on synthetic vulnerability samples rather than real-world vulnerability samples. The contributions of this study. We are the first to use GCN and GRU in our PHP work for vulnerability detection. As we all know, PHP is a scripting language which is very different from Java or C, where similar techniques have been used before to detect vulnerabilities in them. You're also able to embed syntactic and semantic information of the source code in our detection model. We're able to analyze the impact of different dataset distribution, namely the SAC dataset and the Git dataset. We also compare DeepTective with existing vulnerability detection tools. Lastly, we were able to discover several novel vulnerabilities throughout the study. This is the model architecture of DeepTective. The architecture is divided into three sections. The first is input section. So the input contains two types of inputs, the code tokens and the control flow graph. These inputs are then passed to the neural network section. The code tokens is passed to the bidirectional GRU to learn syntactic and structural information of the source code. Meanwhile, the control flow graph is passed to the graph convolutional network to learn the semantic and contextual properties of the source code. So in the output section, the model will perform multi-class classification where it will try to classify each source code whether it is a non-vulnerable or it contain SQL injection, XSS or OS command injection vulnerabilities. In this study, we use two different datasets. The first dataset is a synthetic dataset that we got it from Software Assurance Reference Dataset, SAT. The SAT dataset consists of synthetic samples. It is short and standalone codes, and it does not have any external dependencies, and it does not represent real-world vulnerabilities. However, the second dataset, the realistic dataset, we mine it from open source GitHub repositories. It consists of real-world samples, and it might be long or short, and definitely complex in nature. And it does contain external dependencies, and it does represent real-world vulnerabilities. Here, we will report the experimental results on SAT plus Git dataset. We would like to highlight three different models, File S, File G, and File A. File S was trained on SAT dataset. Therefore, File S is good in detecting vulnerabilities on synthetic samples. Meanwhile, File G was trained on Git dataset. Therefore, it is good in detecting vulnerability from real-world samples. So from this, we train file A, where we train it with SAT plus Git datasets. And yes, file A works well in detecting vulnerabilities across synthetics and also real-world samples. We can see this from the accuracy and recall and also F1 scores of file A. They are significantly higher as compared to file S and file G. Because of this, we have selected file A as our main DeepTective model for this study. Next, we perform comparison of DeepTective with different vulnerability detection tools on SAT plus Git dataset. So we have two types of tools here. So the first type, which is the machine learning tools that consists of TAP and WireCamel. The second is the static analyzers, which consists of ProbPilot, WAP, and RIPS. So based on the comparison, we find that DeepTective outperforms all the tools in the comparison on this dataset. We can see the accuracy, recall, and F1 scores of DeepTective. They are significantly higher than all the tools. However, it is also important to note that we may not have used the tools on what they are good at, right? Or with the right parameters or such. Plus, it's on our own data set. Therefore, they have similar constraints as in other related works. Next is the limitations of the study. The first limitation is the label trust issue on the SAT dataset. So SAT dataset was generated by an automated tool. Therefore, an automated tool might have misclassification or mislabeling where they're trying to create the dataset. The second limitation is that in the wild test, DeepTective will not be benefit from SAT because SAT contains synthetic vulnerabilities. Therefore, synthetic vulnerabilities will not be able to contribute to finding real-world vulnerabilities because the structure is very different. The third limitation is the arbitrary model parameters. Some of the model parameters that we use in our model is a bit random, but we choose it because it works well with DeepTective and it works well also in detecting these synthetic and real-world vulnerabilities. Lastly is the vulnerability discovery. So we run DeepTective on 5 selected WordPress plugins and analyze 1,701 functions. From this, 277 were reported as positives. So from this 277 positive, we manually inspect the source codes and we discover and able to confirm 4 vulnerabilities. We have reported these vulnerabilities to the respective developers, and 2 were publicly acknowledged and we disclose them here in the study. The first one is the SQL injection in payment form for PayPal Pro plugin. It has a severity score of 9.8. And the second one is cross-site scripting in WordPress plugin, where it has a severity score of 5.4 medium. With the discovery of these novel vulnerabilities, we found that DeepTective is reliable to be used in the wild and assists software engineers in detecting potential security vulnerabilities during the software development phase. With that, thank you.